Pointers in C, the topic that scares almost every BTech student. By the end of this video, you will see why that fear is completely unnecessary. Here is the truth. Pointers are not conceptually hard. They are just taught backward, straight into the syntax before anyone explains what's actually happening in the memory. There are two paths: memorize the syntax and hope that somehow it will stick, or actually understand the physical memory and what exactly a pointer is. We are doing the second one, and once it clicks, I promise you, it never goes away. Let's start before pointers even enter the center stage. Think of a hostel. Every student has a room number, and inside that room is the student themselves. When you write int age equal to 21, C does something similar. It stores the value 21 in a specific room in memory, and that room has an address. Let us imagine it is 0x100. The room number is the address in that hostel. The student inside the room is the value. Every variable you have ever created has both the address and the value. You just never had to think about the room number until now. So, what is a pointer? Think of a hostel warden's register. The warden does not keep all the students in their office. He keeps a list of room numbers in the register, where each room number represents one student. A pointer works exactly like that. A pointer is just an entry in that register. It does not store the actual value. It stores the address of that particular room, the room number. So if PTR is a pointer to age, then PTR is simply holding the address of age, that is 0x100, the room number where age actually lives. Two symbols confuse everyone: the symbol ampersand and the symbol star, which are used for different purposes in different situations. Like, you must have used this symbol for logical AND operator as well as for relational AND operator. And you must have used this symbol before for multiplication. And so, when we are using the symbols in pointers context, it kind of confuses in the beginning. Let me tell you that these two symbols do opposite jobs. And means tell me the room number. So, and age gives us the address of age, which is 0x100. Star means go to that room and tell me who is inside. So, we already know that if pointer is holding the address of the age, that means pointer is holding 0x100. And so star PTR means dereference, or in simple terms, I can say value at. And so star PTR will go to that room, go to the address 0x100 and get the value inside, which is 21. And so it returns 21. Asking for the room number versus physically walking into that room to find the value in. That's the entire vocabulary. Pointer. Int star pointer. It declares a pointer that will hold the address of an integer. It takes the room number of age. So PTR is like a sticky note in your notebook with a friend's room number written on it. Whenever you write star PTR, here the symbol star is dereference operator. And in simple terms, as I mentioned earlier, we will use it as value at. So whenever you write star PTR, dereference operator with PTR, you are using this sticky note to walk over to that particular hostel and check what is inside that room. Here is a classic bug: dangling pointer. Imagine you wrote down your friend's hostel room number last semester. This semester, your friend has checked out. from that particular hostel room, but you still have the same room number in your notebook. If you walk over expecting to find your friend, you might find nobody, or worse, a completely different student must have moved in. That is dangling pointer. A dangling pointer holds an old, unupdated address, but whatever used to be at that particular address is gone or replaced. So, dereferencing that particular pointer's address will give garbage data or crash the program. And let me write it down for your reference. This is one of the most common real world C bugs. A null pointer. A null pointer is a pointer that deliberately points to nothing. How do we write it? Let me write it down for you. Imagine that there is a pointer of integer type. Okay. And when we assign it with null, this is a null pointer. What is the meaning of it? This pointer is not assigned with any address. That means this pointer is not referring, not pointing to any existing address. It is not referring to anything. Like an unbooked seat number on your train ticket. It's not an error by itself. It is actually a good practice. Why? Because it clearly signals that PTR is unassigned, not assigned yet. So, what exactly is the bug here? The mistake would be, the bug would be if you try to dereference a null pointer without checking first. So, always check the ticket before you try to sit down. That means always check before using a pointer. Always check if it is a null pointer before using it, because your program may crash. Here is where it gets genuinely useful. Picture a row of shops in a market. Shop 101, shop 102, and shop 103. Each one right after the other. In C, an array works the same way. ARR of 0, ARR of 1, and ARR of 2 sit right next to each other in memory. And the array's name, ARR, basically behaves like a pointer to the first shop of the row, shop 101. This connection between arrays and pointers is exactly what makes C so powerful, and exactly what confuses people who were taught them as two separate topics. Now, pointer arithmetic. Pointer arithmetic is not just adding one. Think of a train coach. Berths are numbered. It is a fixed pattern. And moving to the next berth means moving by a consistent gap, not a random jump. There are two coaches in a train, and both the coaches have the seats between 1 to 70. Suppose that you are at seat number 8. You, by mistake, came to this particular coach seat number 8, but you had to actually go to this coach seat number 8. Then you will jump an exact distance of 70 seats, and then you will land up exactly at seat number 8 in the next coach. And that is how pointer arithmetic works. Imagine PTR is an integer pointer. Then PTR plus 1 jumps forward, jumps by size of int. Usually it is 4 bytes. So it will jump by 4 bytes. If, let us imagine, pointer is a character pointer, then just like always, it should jump by the size of the data type. That means it will jump by size of char, which is 1 byte. And so pointer plus 1 means it will jump exactly by 1 byte. The compiler automatically scales this jump based on the data type. That's not random. It is precision engineering. Now, here is the real payoff. Why any of this matters in actual programs. Normally, when you pass a variable into a function, it is passed by value. It's like handing someone the Xerox copy of your secret recipe. They can write on it, mark it up, do whatever they want, but your original recipe stays untouched. But if you pass a pointer, it is like handing them the original copy of your secret recipe. Now, whatever changes they make actually affects the original copy also. This is how you write functions that genuinely modify data, swapping two numbers or updating the shared values, or even build real data structures without infinite copying. This is where pointers stop being theory and start being tools. Think about Swiggy or Zomato, food delivery apps. They track your order live. The app isn't repeatedly copying your entire order data every second. It's updating a reference to the current status in real time. That is the same efficiency principle behind dynamic memory allocation with malloc, linked lists, and passing large data to functions without copying it. Everything you will need for DSA and real projects sits directly on top of what you have just learned. Pointers. Pointers are not the scary part of C. They are the part that makes C powerful. Once you actually see what's happening inside the memory. In C and C++ Foundation Batch, we don't just draw these diagrams. We build real programs with them from day one. Book the free demo class or check the class pack available at my Urban Pro profile.